Okay, we're doing a little Axeman Anderson experiment here. We're going to bring this piece of 1940s technology into the 21st century. Well, at least we're going to try to. We'll see how it goes. I bought 3 of these Inkbird PID control gadgets. And I got this one bugged together here. I pulled out the single aquastat that I was controlling the boiler temperature with. Pulled the 2 wires off of the temperature switch, hooked it to the solid state relay output. Pardon me. Whoa. That was the hashing relay. I have the auger turned off right now just for this little experiment. And so right now that is our current boiler temperature. I turned the monster radiator on for a little while to pump the heat out of the boiler with the switch shut off, so I could run it. I could see if it would run and how well it would control. So right now we have our, we just have, we're not using the PID function. We're just trying it as an on-off thing just to see how it works. So our set point is 160, just like it was on this one, 160. And currently the boiler's temperature is rising, 104.8, 104.9. And I'm not sure how you get the PID function to work on this, because what it does is it actually changes the percentage of on. Right now if we press set, this setting here means that it's providing 100% power out of the solid state relay. Now I first had it on PID mode, and what happened was the motor came on. It was kind of close to the set point. We were actually at about 156 degrees and the set point's 160. So it was trying to slow down, which is what the PID does, which is actually a really good thing. I don't know how well it'll work with these motors though. So basically when I looked at this setting, it was showing 15% it was trying to send to the motor, and the motor was not turning. So I shut it off right away. Went into the settings and set it to on-off mode rather than PID. So we'll see how well this goes, and then I guess after that we'll figure out how to do the PID thing. And if it all works out, we'll wire it in all permanent like. Oh, they're multiplying. I have 2 of them temporarily bugged in here. This one is still controlling. This one's taking place of the aquastat right now, and it's running through this 25 amp solid state relay. So basically what was connected to the switch in the aquastat is now connected to the output of this solid state relay. So whenever this shorts, when this tells it to, everything turns on, and the Stoker runs until it gets close to the set point. Then it starts shutting off for a few seconds, like 15 or 20 or something like that, to try to anticipate the overshoot. I haven't seen it eliminate the overshoot or even come anywhere near eliminating it yet, but we'll see. I don't know, maybe it does. And this one, since we had a repurposed aquastat actually controlling the ashing on this for I don't know how many months now, probably 6, 8, 10 months or something like that, I decided just to use one of the other ones that I had that doesn't have a solid state relay. It has a solid state relay inside of it, and it's plenty powerful enough to, I mean, this is just a 24 volt AC heating system stuff, so it can definitely handle that. So So that's, I just pulled the aquastat out and I put the temperature probe, it's a K thermocouple, into the pipe that the aquastat was in. And according to my temperature gauge here, they don't really agree too much. What's that one say? That says about 124, 125. This is saying it's seeing 116.9. So since this is reading slightly lower, I set this at 110 degrees rather than like 100 or 105 or whatever the aquastat was at. So we'll see how this works. I'd like to kind of do a video of what happens when they get close to their set point, because I'm not always here. I saw it once with the aquastat one, and it was kind of interesting. It would shut off for a few seconds and then come back on, and then shut off and come back on. So we got to make sure that it's not like a real jerky on off, otherwise that could cause mechanical problems. But yeah, we'll see.